So how many of you were able to access the site, the YouTube site? Sound, I think the sound is actually a little too clear. You could hear people from very far away talking about things they probably shouldn't be talking about. Just be aware that it's being recorded. But then again, be aware also that probably no one's going to go through an hour's worth of video on game theory unless they also are nerds, so they probably won't care what you said over in the corner in the first place. Like my, turn this on.
There's so many people.
Yes, you know why it's small? Linear algebra is a prereq.
And operations research.
Linear algebra is a prereq for that one too, right?
Yeah, I think so.
That's pretty big.
It's a small class.
Linear algebra is a prereq that really kind of weeds out. Someone can't just finish Calc 3 and come into the class. They have to have linear algebra too, right?
What's operations research?
It's really cool. So if you are in a business, for example, and you wanted to make profit, that's the idea. Well, you could simply just make a lot of the product, but there's constraints on making the product too. You can't just make lots and lots of product. The cost will also go up. So it turns out there's an optimal sweet spot where if you sell this amount of product, you're going to maximize your revenue and minimize your cost and thereby maximize your profit. So that's where it's typically used. But I can think of all kinds of other applications for operations research. And it's a good class to have because if you just do monster searches on who's getting hired or what they're looking for, there's a lot of operations research people being hired in, like AT&T is hiring them. I see them on Monster for stuff like that.
We dropped statistical computing.
Go take.
Yeah.
Yeah. And I'm sticking it out.
I don't want to code. Coding.
Statistical computing is probably good too.
I dropped it, then I had it back.
I can't drop it because then I don't graduate.
I don't like coding. It's always like Java.
But again, the jobs are out there for that.
Yeah.
You'll never hurt for a job.
I don't have the patience to sit there and.
Every state and hypothetical. I'm feeling my class is going to be so much smaller on Thursday.
Let us know.
Nothing showing up yet?
No. I have so many.
Oh, well, we need to plug in first. That would help.
But I looked at him and I was like, oh my god, you are Peter Pettigrew.
I said.
Well, I didn't say his name.
Were we recording when we were in your linear algebra class?
What?
Were we recording then? Were we doing these recordings then?
Yeah.
Didn't we say that?
Every single time you ask a question, you use my name.
Yeah. So that was what we used in the linear algebra class. So before you say something that might be offensive, just say, "This is Tyler, and I'm about to say something really offensive." So he gets all the blame. He's okay with it.
Yeah,
It's not a bad thing. It just shocked me.
Well, if I leave here and I see a Rate My Professor saying that I look like Peter Pettigrew, I think I'll cry myself to sleep. Because I looked in the mirror this morning and I don't think there was a resemblance. I hope.
It's not you.
But then again, I see people on TV sometimes think they got on TV and thought, this is my best outfit. They looked in the mirror and thought, I'm going to be on TV today and this is my best look that I have. So maybe people don't know. Maybe I do look like Peter Pettigrew and I don't know. And someone has to tell me. Okay. Thought you might like my game theory, Game of Thrones. So I wanted to go over some of the solutions to the unassigned problems because I wanted to show you methods of how you would look at one of these problems and solve something. For example, what would a tree look like for cram? And some of you actually did this on your in-class assignment. You would just, I just left out the shaded parts, and you can see what would happen in this case. They drew the symmetry in. This is something that you can find on their website. So they drew the symmetry in. I wouldn't draw that. For example, a vertical could go here, a vertical could go here. And you really don't have any more choices. They just drew it 2 more times over here because of the symmetry. You could have the other one go first and this one goes second. But it's not that big of a deal. I would just draw this part. And then from there you could say another vertical could go down here, or if that was switched around by symmetry, you could have the first vertical go down here and the second one here. I would not have drawn those symmetrical pieces because I think I would have drawn the least amount. I like something like this better. What are the possible moves on this thing? Well, you could have a vertical here, and a horizontal here. Those are the only possible things you could have on your first move. And then your second moves with verticals and horizontals would look like such in the second layer of the tree. It's more informative. As you go through actual homework problems where you're trying to solve something or when you're doing something on your own, you'll see that the tree drawing is for yourself to keep track of it so that you know that you caught all possibilities. And the way you draw that tree is going to be dependent on what you're doing. So because you want to solve a problem with the tree. You're not drawing the tree just for the sake of drawing the tree. So I guess the real question that we all had is, what, if any, is a winning strategy for player one, right? You want to play the game with one of your peers, pretend like it's a real game, but know that you're going to win the first time, that it was all over the second they said, yes, I'll play with you, right? That's what you really want to know. So that's the question. So I went to a 4x4 because this is what we would do. We would, instead of starting with a big 8x8, I'd want to figure out what happens with a 4x4 to see if I could find a pattern. And what you can find is, did I bring it? I think I did. I told you I always lock it up in my office. I forgot to today. You can actually get these as apps. They're free apps. So I started playing a lot and trying to figure out, you can make the size of your domineering 4x4 and just play around with it. What I noticed is if I was horizontal first and I just put somewhere in the center, it seemed like I could win. And what I thought is, if I wanted to prove this now. Is it true that if I start in the center, I'm going to win? And when I did this, I thought, well, there's really two centers. There's this center and this center right here. There's not a really straightforward center, but I kind of felt like when I put it somewhere in the center, I ended up winning. So if I started out with my first move being this, well, then the second moves would be, I could put a vertical here. I could look at all the possible places for the second move and draw it out in a tree. It starts to get a little messy. My tree gets messy because I had a finite space there, but you see the point. And some of it's symmetry. I'm trying to solve a problem. So I don't have to draw the tree out for every one of these. I just need one winning strategy. And so I kept going with this. I just picked this one over here and said, what could come next if this is the piece that I started out with from here to here? Well, I could put a horizontal here, for example. That's one strategy. And if I put the horizontal here, then these would be my series of next moves. So I'm not following down all the trees. I'm following a very good hunch and seeing if I end up winning, no matter what the verticals do. That's the object in drawing my tree. Is it making sense? Have I confused anybody? So really, if you wanted to really draw out all possibilities, you'd have to set out some paper and really draw all the possibilities. But since my hunt was for a winning strategy, not all possible strategies, I'm just looking for a case where no matter what the vertical does, I'm going to win. So I kept going on that one tree path. And this is what I get for next move. Next move. And I see that vertical will win. So that wasn't a path I should follow. That's what it told me. But I went back and said, can I screw them up? What if I took a different path? Instead of putting the horizontal I started with over here, what if I put a horizontal here? Will that make it so the vertical can never win? Well, the vertical could go there. It could go on the, it can really go nowhere else, right? The horizontal could go here, and then I'm done. I've screwed them up. So now I've got a winning strategy. No matter what the vertical does, I will win. So my guess is with the symmetry, it's not a guess. I've proven it now. That if I start with two horizontals right here and here, no matter what the vertical does, I will win. Like it? So what I'd like you to do now is to tell me if this is the only winning strategy. So this is what I started out with the two, right? I guess that I don't have to draw it again. I know that if I started out this way, it would be, I could just move around the verticals the same way I did before. It doesn't matter. This one or this one's gonna mess up the person. So see if you can find another winning strategy where horizontal goes first. Let's do it this way. This side of the room, right over here, split by you. You're on this side of the room, right? Tyler, you're on that side of the room. You guys have time. And see if we can develop a winning strategy. You guys try to find another winning strategy with horizontal. So when we finish this part of the in-class assignment, you're going to say yay or nay. There's no other winning strategy except for putting the horizontals in these formats. And you guys try to figure out what would happen if the first player started vertical. Is it possible for the first player to win vertical doing the same trick I just did with the 4x4? With 4x4.
But anyway, or does that have to be on the inside? Right in the middle.
Well, that was a conjecture that I came up with playing for a while, that it seemed to be that I had to smack dab in the middle somewhere. I'd have to start it.
I said the same thing.
I would guess something would be similar with the verticals, that you'd have to start it somewhere in the center. 4x4.
And this is the same thing, our partners.
Yeah, partners, same thing. In-class assignment with partners.
Go vertical
There's
first.
little fringes on the paper.
You can set up with Will.
Go vertical.
You can stay on their side of the room.
This is us.
Yeah, you're gonna try horizontal. Are these the only two winning strategies? Or no matter what the vertical does, I win. Is this the it? Have I exhausted? For example, could I have done this and this, or this and this? Could I put a horizontal here and a horizontal here? And still make that the case happen that the vertical cannot win no matter what you do.
Follow the line.
Yeah, no, but drawing the vertical ones is the hard part.